welcome back to Algebra 1. This is our last section for exponents. Once again, this is a really important section. A lot of things deal with exponents, both in real life and in our future math classes. And if you don't plan on taking Algebra 2 for whatever reason, statistics, I would really highly recommend that you take a finance class where you can learn a lot more about some of information, where it comes in real life, because it is going to be important to you. I know it might not seem like it now, but it will be later. Let's talk about something called a geometric sequence. But first, we have to remind you what an arithmetic sequence is. So, arithmetic sequence is a linear equation where each term after the first term is found by adding or subtracting a common difference. So, we have some initial amount, okay, our y1, okay, and we're adding or subtracting a slope, okay, to our initial amount, right? It's a function of a linear, function. But now we're going to talk about geometric sequences. So geometric sequences, unlike arithmetic sequences, is where a number sequence in which each term after the first term by multiplying the previous term by arithmetic sequence, we're adding, here we're multiplying. And so let's determine if each of these is an arithmetic or not. Okay, so what we find out is we can add or subtract and see if, what we're doing to get there. Okay, so the first thing I would do is say, okay, well, 3 to get to 2. If it's an arithmetic sequence, I would have to be subtracting or adding a number. So 3 to 2 would be minus 1. 2 to 4/3, that's not minus 1. Okay, so we know it's not an arithmetic sequence. So now let's check and see if it's a geometric sequence. Now there's a chance it could be neither, okay, because we do have other types of sequences. Okay, so to do this, we're going to take this and we're going to divide it by the first term, and we get 2/3. Then we're going to do the same thing again, okay, but we're going to take the third and we're going to divide it by the second term. Okay, and we never divide by a fraction. We always multiply by the reciprocal. So 4 times 1 is 4. 3 times 2 is 6. That, and we get 2/3. Well, those two things match. Okay, so if we multiply 3 times 2/3, if we multiply 2 times 2/3, we get 4/3. Okay, so to find that number, or to find out if we're multiplying by the same number, we can always divide, okay, the next term by the one before it. Okay, and if we do 8/9 divided by 4/3, we're going to get 2/3. Okay, so this one right here is a geometric. Okay, because we're multiplying by 2 each time. So now let's check first. Check if it's arithmetic first, because that's always easiest. To get from 3 to 4.5, I would have to add 1.5. So to get from 4.5 to 6, okay, I would have to add 1.5. And I can do this the same way, so I can start with the second term, and I can go 1.5 minus 3 is 1.5. Okay, as long as that number's the same, then it's an arithmetic sequence, because I'm or subtracting that same number every time. Okay, once again, you might get some that's not geometric. Other types, those are just the two we're talking about. Okay, so let's talk about geometric recursive formula. Okay, so this right here looks pretty similar to that, doesn't it? Okay, it's very similar. Okay, so the geometric formula, okay, recursive formula is just a sub n, and it equals r, so that's our common ratio, what we're multiplying by, times our. Okay, so here, let's rewrite the recursive formula for this. Okay, so a sub n, in other words, what additional value? Okay, to find that out, I'm going to take my second term, and I'm going to 8 are both divisible by 4, and that gives me 3 over 2. R is 3 over 2, whatever my previous term is. Okay? That's it. That's all I have to do for a formula. But now I want to write an one here. The only thing missing is x. Okay, but in this it actually, okay, so in our ratio, whatever is 1. Okay, so let's take a look. So this is the term or the third term, right? Doesn't matter. We're going to take one term and by the term. And we've already done this one over here, so we get 3 over 2. So now let's go on ahead and our a sub n formula, we have to write our before we can find the 10th term, is 3 over 2. Oh, over 2 is our first term, which is 8. Okay, 1 is 8. Times 3 over 2 to that n minus 1 term. Okay, so that's our formula. Okay, so now let's go on ahead and find a sub our 10th term here. Okay, so that's going to be 8, 3 over 2 times 10 to the 10 minus 1. So let's go on ahead and plug that in. So 3 divided by 2, I'm just going to change that into a decimal, is 1.5. 2, and then is 307. Do it exact too. It's going to be close. So it's approximately. Okay. So that's it for chapter 6. It is important that you remember these formulas, but okay, the recursive formula always the rate multiplied by the term before. The explicit formula is the first term times the rate raised to the term before the one you're looking for, or the term number before the one you're looking for. Okay, you guys have a great day. I will see you next time.